Very good.
So you are aware. Yes, welcome. This system engineering community is organized by me and Magnus, and we have made an agenda. And now I shall. So where we start with a welcome, and then we will look into two cases. Since we are both working as system engineers, we have picked things from our everyday life that we can discuss. Then we look into why is this community existing, and we are also interested in discussing a workshop in between and what that can look like. Do you want to organize on the table, Magnus?
Yeah, we thought we will make it very, very simple to, if you just write in the chat in one short sentence, not your name because the name is already visible, but what you're doing in one short sentence, instead of just everyone talking around the table because you know how it is. Sometimes you forget after 3-4 people have talked. So let's try to just type one short sentence what we're doing in the chat, and then everyone can see that. I was first. This way it's probably also faster than going around the table and asking everyone one by one. For those of you who just joined, dropped in now, we're starting with a welcome around the table, but instead of going around the table and asking, we just suggest that you write one short sentence in the chat, what you work with. I'm not sure if the chat is saved as part of the recording.
Don't think it is.
Anyway, it's no secrets, hopefully, for a job title. Lots of interesting stuff here. Okay, it seems that we're not getting more comments, so just please take a look, and it's nice to get a quick glance, quick overview of who is in the meeting and what you work with. That took 1 minute. That was very effective, I think. A couple more coming in. Okay, how about we jump into the first case?
Case one. I'm working with the microwave transport, and that is to connect. The main thing is to connect the radio base station with some centralized system, and we are working with microwave. And what we are starting to do is actually to collect, and I'm working in a program project that has been started up by research, where they have made an AI algorithm based on data. It's a clever thinking, but now we want to productify this. So I have spent time on that, and one of the designer come to me and told that the data doesn't fit together in a way that we need. And I started to look into the problem because it seems to be a bigger problem that the small thing he have done. And the architecture is basically that we have, say, 3 different products in customer network, and we have a couple of million of those out in network. So it's a big business if we can leverage on that. We have a collector system in the field today that can be sent to a data lake. But then we suddenly have a new collector on the way out, and that is on a silo to another data lake. And then we had a special collector, and that is sent to a third data lake. At the end, we do some data workers that run algorithms on that, and we visualize the result. But the thing here is that we have multiple stakeholders, and they are very independent. So they do independent solutions. So, and that make the silos difficult. At the customer site, we have many different versions of products that are expected to work together with everything, and that make the version handling very complex. And yeah, this new collector it show that we try to introduce new system with new behaviors into this. And I'm sitting basically reading interface specifications and try to follow each and every data flow at the moment to find the data I want to have. And I have found it doesn't exist. So I have to ask for changes. And it's also very time consuming because it changed names and the data is processed in very different ways.
Anders, it seems
Yes.
Recording has stopped. Well, now it's starting again.
It's okay working here.
Okay.
So a little bit it's a question from me to everyone from you. One is if you recognize those problems, and if you have any solution that are more clever than my manual reading, I'm really happy to learn about that. So I open up if someone have a comment.
I guess ideally there should be an interface description for the different products that you want to collect from. And that would be the source of your automatic data collection to select out of that interface description. But then the challenge is, of course, that with multiple products and multiple teams, everyone has their own way to define that interface, and you still need to have the manual interpretation unless you find a way to standardize it.
There are a couple of patterns that could maybe be useful here. One is that to add a harmonizing interface. So if you have 2 different systems, you can unify their output in a harmonizing interface, delivering the same kind of output. The other pattern is, in theory, data lake, you should have one data lake only, but in practice, of course, this is often difficult when you have integration from different suppliers and stakeholders and so on. But that could also be an interesting pattern to look into. What if you could unify to one or just a few data lakes?
But I guess the challenge is both for the data worker and for the collector, meaning that one needs to harmonize already at the source.
Yeah.
Not in terms of the concrete API, but in terms of the interface description, so that one at least can generate product-specific APIs based on that spec.
One thing that I have found is that at least one of those flows doesn't have the identity of the source in the interface description, and that make it very difficult to understand if there is a normally there is a difference in the source because it behaves different in different versions and different products. So information about what is generating the data is important.
Yeah. And I guess also metadata regarding where was the product used and what was the use case, what was the situation, and a lot of other things that could help the, I don't know what the visualization was about, but drawing conclusions out of the data in the lake is easier the more you know.
Is there any, I mean, this way of having distributed and many stakeholders is quite common. And normally we encourage that, but is there anywhere where we have standardization of this kind of data flow? We don't have it, except that we implement standards, but we tend to implement different standards in different products.
In our case, there are various logging technologies in use depending on the purpose of the log data, and these are too much of silos. So again, I guess a key thing is to agree on what is the data and metadata that is required for each of the data entities that you want to log, and then try to preserve that all the way from the product to the visualizer GUI, so that he can, or at least the data worker, that client can get enough data to draw conclusions and decide what to visualize. Or doing predictive maintenance or learning about customer behavior or whatever is the purpose of the data. Or rather, the purpose of the data worker. The data lake should be generic enough for multiple purposes.
I guess that you don't have full control, since there are many different stakeholders involved, that you don't have full control over updates being pushed either, right, to products and maybe collectors.
That's correct.
So you can't trust that a data format won't change from today to tomorrow.
Many times there is a pattern where we add data, so we don't change data. Too many situation has been that people have changed data in the interface and the following system have stopped working, and that have forced us to add data to interface and not change it. So it's reasonable fixed.
So do you have any way to get the people at the product to provide enough information for you to be able to do the work?
So far, I have not. I'm not feeling limited by that, but yes, I also have. But the main problem, I think, is the collectors, that they are designed for different purposes. So they do different things with the data, and they do different things with a subset of the data. And I think my problem maybe is more to push those people to what I want. But it's the same problem basically, but in a different level. I think we shall time box, Magnus, and
Yes.
move.
Yeah.
Thank you for all your comments.
Maybe one comment.
Yes.
Do you have a common data model that you govern?
No.
No.
That is one that would help a lot.
Yeah, I think so. We're having some of the same discussions. And for instance, if you want to do A/B testing, you would need that the data model would contain versioning information, for instance, because you need to know what version the data relates to of a given application in a given product. So and then that would, of course, you talked about not changing interfaces but adding to, but when you do that, you need to also update the data model, because then you have new data, and the data worker needs to be aware of that add-on. So these data lakes, are they completely independently developed, or?
No. It is the flow into the data lake. The data lake by itself is very generic, but it generates, since we need to parse all data, and it generates a flow of data that are independent. So to be able to group data, we basically have to read it out and do something with it. So the data lake is really just a data lake.
Yeah. But I think at least that our discussions are much around concerned with a data model that we can trust.
So Niels, in this data model, how much metadata or extra information do you tag on to each sample, so to say? You mentioned the version, but
Yeah. Yeah, it'd also be product type, product family,
Serial number.
yes, also serial number. So all of these things that will identify where the data stems from. That is, of course, the big task is to make that data model clever, so that you can use it for these many different purposes that were just mentioned before, whether that is analysis of health, or it's customer behavior, or it's A/B testing, or whatever it is.
Okay.
Yep.
That was some good input. Should we move on?
Yes.
Great. So now we come to a case that we have a Tetra Pak, and this is about configuration management. This is really building upon, related to the case that Anders showed in a way, because while we may not have millions of these products at the lowest level, we have thousands of them, and we have variants and versions and all of that complexity. So let me jump into the case directly. So in this picture you see an example of an integrated system at the bottom. I won't explain all the details here, but you can see some examples that we have a production line with a few machines. The machine in the middle is called the filler machine. It has some different embedded softwares inside of it. And each of these embedded softwares may be supplied by a different team internally. So they have each of these small blue boxes, the PLC, the logger, and the HMI, may have their own life cycle and their own release pace. And in this machine, we also have variants and versions and so on. Kits added, so we have that complexity. So, and then to the left, you have a red box called standalone software. Here we have software that is outside the production line. Some of this is running in the cloud, others is running on premise. And this is, of course, a simplified picture just to give you a taste. And then to the right of the picture, you have added equipment as well. The picture to the right is a sampling unit. This is an added equipment to the production line. So in summary, this example shows that we have equipment in a production line, we have embedded software in the machines, and we have standalone software outside of the production. All of this will then work together in a solution that we deploy to the production line. So the challenge obviously is then to how to manage all these dependencies. And that's what we try to illustrate here in the big blue blob at the top. So let's say that we have a product P that we want to deploy on top of this line. There's equipment, we have embedded software, we have standalone software, and we have a thing here called common services. And the blue arrows and the blue dots represent releases. So the good news here is that each of these blue arrows already have a tool chain and a release cycle and version management and all of that good stuff. But what we don't have yet is the red arrow at the top for this particular product. We don't have the life cycle management for the product, the integrated product. So what we need to define are these version numbers for P1, version 100, 110, and 200 as an example, and the baseline connecting the dependent releases within each of the subsystems. Also taking into account the gray arrows at the bottom with external dependencies. And of course the product P, the big blue arrow, comes in different flavors. You have variants and versions of that one as well, so you have to manage this. So the question at the end is what you see at the top. Will product variant P1 work on target environment T1? Hundreds of or thousands of customer factories where we want to be able to deploy this product, and each target environment is a bit different. The machines and the softwares are different, and we test different combinations, of course, in the test strategy, but in the end we have to manage the dependencies, the internal dependencies, as well as the dependencies towards the target environment. So the question here is really an open question for discussion. Do you guys have a similar industries in your companies, and what is your approach? And I should also add here that this is no longer your grandfather's configuration management. We of course want to enable agile development, release anytime. So if there's a software patch, for example, of course we want to release not only the software, we want to know if that software patch works in the integrated product, so we can release a new version of the product as well. So I throw this open question out to you. Do you have a similar challenge in your industries, and what is your approach? I see that Robert raised your hand, but you can speak freely.
Okay, thank you. Yes, we have a similar situation, I would say, to the least. And there are several challenges with this, dependent on how far you want to go in a model-based systems engineer context. I think you could be able to treat it as a traditional, as a start, model-based software engineering or model-based design, but then you are not doing systems engineering. You're basically just securing that your design fulfills the objectives of one particular system, whatever system you decide it to be, which for software would be a configuration of software. If you want to go one step ahead or further in your model-based context, you basically need to decide what kind of boxes you would like to have. Are they still called systems that are integrated? Are they called subsystems? How are systems or subsystems related? Or would you like to go in a modularized fashion? And in that case, what's the difference between a module and a system? And so you would need to set those terms in a context, which for me personally normally is then considered an ontology. If you have that ontology, then you can start to do configuration, because then you can start to address questions, particularly, is this directed towards a subsystem or something in the subsystem or the objective of the subsystem, or is this particularly related to one or several modules? And what's the objective of that question? If you do not have that ontology in place, I think one risk or challenge is that some people will address subsystems, some will address systems, and some will address modules, and you will not really know where the problem belongs. That's not meaning that everybody addressing a problem will not have a reason for that, or be doing that in a fair or with a with a good intention. Nobody's there to destroy things. It's just that if you don't have the language to express the particular issues, my experience is that you spend quite some time defining the problem before you can actually address it. And if you do not have the ontology in place, my experience is also that you do the solution at a single point in time, which makes it difficult to walk between P1 version 1.0.0 and P1 version 1.1.0, because if you solve it in one setup, you're not sure to be able to bring the solution to the second setup. So in this particular case, if I compare to what we are trying to do at Volvo Cars, we are establishing a language to be able to do this in a model-based fashion. Thank you. That's my comment on the presentation.
That's great advice.
Or the question back: have you such an ontology in place?
We are definitely working on it. Yes, so we are aware of the this challenge that you mentioned, and it's clearly a piece of the puzzle.
Would you like to say something about that? Because I'm quite curious about what kind of words have you chosen and to describe these things, and how do they relate?
Maybe we can come back in a deep dive session if people are interested in this particular kind of problem, where we can discuss limited time.
Thank you.
But that's a good one. I would like a deep dive session on that.
Is there a risk, you could say, that the parts of the physical stuff will change as well?
We have control of all the parts in this kind of system.
So this means if a circuit board is shifted due to some kind of service from an old version to a new version, then that would be handled at the time of service, and you would know from the clouds controlling this, I suppose, that happened.
Yeah, we have that maintenance management system tracking those maintenance events, but we haven't integrated all the silos needed yet.
Yeah, okay, because in our world we have a lot of systems that are not connected, but only sporadically connected, you could say. So when a service guy comes to a system, you can easily imagine that there would be an exchange, and then at a later point in time there would be maybe an attempt to update, and you wouldn't know.
Yeah.
Okay.
Yeah, that's of course the part of the reality. What you don't know, you don't know. That's it. You know the last known state, but it might have happened stuff since then. Yes. So I think my time box has ended.
I just want a short comment, Magnus. I'm Baldwin from Axis in Lund. If it wasn't for the pandemic, I would definitely go and buy you a beer, because we need a lot of time to talk about this. We come from a completely different approach to this from Volvo Cars. I'm not really sure which is most appropriate for any single company, because we all have different context, but we have a much less control over the end system that is built, and we have 3,000 different partners that develop software that integrate with our stuff. So in a way, we are more similar with the interoperability problems that somebody like Microsoft has, that has a huge ecosystem. So we don't have as controlled approach, but we have done a lot of work of just trying to keep interoperability and compatibility between different components and that kind of stuff. So of course, for the sake of time boxing, I'm not going to go into any of the solutions, just leaving it as a teaser for you to feel free to get in touch and have a discussion on this.
Good, thanks.
Or maybe we could have a deep dive session within this community about this subject.
Yes, of course. And I would love to have beer with you again as well, Niels. You know that.
Yeah, I know.
Okay, guys, it seems that we have similar challenges. So, and also this connects to the challenge that Anders showed just before on the products that you are trying to track, where you also don't have the full knowledge of what they are. So let's try to arrange a deep dive on this subject.
I'm just a little bit later. I try to build a system on existing systems. I have borrowed slides from Jan. Why do we have this system engineering community? And the idea is to meet twice a year, and we have done that on different companies, except for this year where we have had this COVID problem, but we need to find a way to solve that. And the community is open, and the idea is to share the best practices across different domains. The implication on building a system now is that you recognize the waterfall-driven IDs on the left side and the agile IDs on the right side, but we also have this kind of ecosystem and data-driven decision making. And right now we are talking about a lot of data-driven decision making. And one of the challenging problems is how to evolve a system that consists of different things with very different speed in the how often we can release something. Mechanics, electronics, and software have very different pace, and what we have done so far, I think, many times is to update the software often. We have a system where we exchange electronics, but not the mechanics. But in the real perfect world, we maybe should be able to update also the mechanics. So the question is how, in the system engineering community, we can find a way to actually evolve all parts in the system.
Release anytime.
Release anytime. Do you want to add something, Magnus?
No,
More?
that was good.
And now, Magnus.
Yeah, so we tried to summarize here the different objectives that we could agree upon today. So, but we don't have a good voting system in Teams today, so maybe we just take an open discussion verbally on what you guys think is the most interesting and important thing that you would like to focus on in the future. So the objective for this community. To the left, you see the two cases we have today. The case 1 from Anders, case 2 from me. And to the right, you see more generic systems engineering challenges that we picked up in previous sessions from you guys. So take a minute and take a look at this, and then we can just give comments, and I will try to take notes to see which ones are most popular.
How many votes do we have?
Let's just speak openly to start with. Maybe we don't have to do a formal voting session. We can just speak freely.
If I understand it correctly, then your case, which is today's case number 2, is very much related to this point 3 in general. Is that the correct understanding?
Yeah.
Yeah, especially the cyber-physical nature of, or the configuration management in a cyber-physical context.
Yes. It's not your grandfather's configuration management.
Oh, there's at least one more dimension, maybe, to it.
I really like the cyber physical aspect. I think that's a good, and especially in a system of system context, because I think several of us will work in environments where we need to collaborate efficiently, which will challenge the business cases that we have currently, and that will probably drive needs to be able to talk openly without challenging each other's existence in a rude way. So I particularly like the cyber-physical systems and system of systems, because if we can sort out the language for that, I think it will be much easier to talk about forces that is driving parts. I think when it comes to details of systems and how you declare the partitioning of your system view might differ a lot. But from the architectural point of view, I think we have similarities in how we want to declare principles. But how we divide our product may differ totally. Like, for instance, we had a case last year where Volvo Cars and Uber treat their architecture description totally differently. But in a system of system context, we could still collaborate if we were using terms that were agreed. We could use our internal structure for architecture descriptions, and they could use their internal structure for architecture descriptions, and we could still collaborate in a safety critical domain. And I think that kind of reasoning is very interesting, and I think it's very immature in a system of system context. When it comes to system of system context, where you have a strong leadership and shared resources, like a directed system of system, then it's pretty much just a large system. You can use the same principles, but when you come to loose system of systems like virtual or collaborative system of system types, then I think it's a much bigger challenge to effectively actually collaborate and to thrive in business mutually.
Because when I was looking at these various challenges or objectives, then very many of them are related to the product description or architecture description or data model, as we discussed in case 1. So to me, it would seem like an enabler to be able to transform or project our various parts of the systems into a common notion. So when we talk about a certain configuration, then we know which hardware entities, which software entities, how are they parameterized or configured. When it comes to 4.5 with a VNV, which tests are applicable and what test data or log data have we collected? So to me that looks like an enabler to succeed with this, but maybe interesting to also look at hybrid approaches where different parts are described differently and yet we can manage the properties of the system.
Yes, I'm taking notes, so feel free to give more comments, what you prefer to work with.
Yes, of course, you'd easily get around to many of the topics listed here. If you dive into one of them, you'll probably meet the others on your way. But I would prefer today's case 2 in the context of topic 3.
In the context of
topic 3.
Subject 3, yes.
Yeah. So I think like Balvin says, that these two are natural. They're connected in a natural way somehow. So I think that case 2 is really, really interesting.
Yeah, I suspected that we have a similar challenge in different industries.
And wouldn't also many of the 4 topics touch on the 3 topics? As you said, starting to look into 3.1, 3.2, 3.3, 3.4 would typically involve 4.1 to 4.7.
Yeah,
so
I think, as you said, the number 4 is they are enablers. They are like systems engineering principles and best practices that will enable the area number 3.
Yeah, I agree.
Okay, but I think Jan will be Jan Bosch would be quite happy with this because his baby from the start was how to do continuous improvement post deploy and release anytime. So the number 3. And then of course, as you said, this will definitely touch upon different other areas as we go along. Anders Kvist, what is your reflection on this? I think you are muted.
I'm muted.
Yeah.
I just kind of agree. I don't have too much more to add. I think we are kind of the spot of what we have as a problem when we try to connect things distributed.
Okay. I think that leads us into the next slide, which is the next workshop. This is the end of our presentation. So it seems that the next workshop will be a more deep dive in the areas we just talked about. So
and then I guess the question is how to organize that. Previously, we have been meeting on a company that have hosted the meeting, and that has been very interesting. But this time, I guess we need to plan for a virtual meeting,
yes.
and that is kind of easier in the hosting situation. But still, someone need to prepare different activities. Normally, it's very good if someone can present one case, what they are doing and what problems they have, it normally is enough to make the discussion starting.
Yeah, as you noticed, we like to, Anders and I, we just like to jump straight into a real case instead of starting with 3 PowerPoints before. So I think, but I can take it upon myself to propose a next workshop and email to this community and check and book a date. And maybe something like 3 hours could be reasonable. And that would then include a couple of breakout sessions, I think, so we can discuss maybe just 2 by 2. It seems like we are maybe 10, 20 people in total logging on to this session now, so that could be reasonable.
To say if the subject would be what we just discussed, I'm sure that I could interest a number of my colleagues to participate from different parts of the organization, covering this entire scope.
Very good. So, but I like to do breakout sessions, so I think even if we're 30, 40 people, we could still make it work with breakout sessions. It's just that they will be a bit bigger then.
Yep.
How does that sound to you guys?
I'm thinking about the timing. I don't have a strong opinion, but what about 1 + 2 hours versus 3 hours? Could that be an advantage? To leave some time for reflection before going into the
yes.
long session.
Mm.
Maybe it adds complexity in the scheduling.
Yeah.
So are you talking about sessions separated by a week or 2 or 3, or what are you suggesting?
Probably 1 week rather than 3, but
okay.
Just some time to be able to prepare and reflect.
Yeah.
But it does add one more calendar event, and maybe it takes away the spontaneous flavor of the meeting. I don't know.
I can hack together a quick doodle to check for dates that you guys are available, and then I can just book a couple of sessions, no problem. I think that's a good suggestion.
It's a possibility when we don't need to travel.
Yeah, it is. It's an opportunity. All right. I think that's it.
Thank you.
So
Thank
someone,
you.
okay,
Ciao, ciao.
thanks a lot.
Thanks
Thank you
for
for a great session. Bye.
Bye-bye.
Bye.
Bye.